What's going on, dudes? How's it going with you? Can you hear my voice? Can you see my face, or at least see the whiteboard? Alright, here's what the plan is. I'm going to go and record this, and we're going to try to go through as much as I can, as much as humanly possible. Here's what my plan is. I'm done. I'm done covering polynomials. I won't cover any new topics with you until January. I think that in January we're going to hit rational functions, and then we'll get to exponentials and statistics a little bit. But pretty much I'm done with teaching you new stuff. This week what I want to do is we've gone into more of a, I'll tell you if you take, okay. This week we're going to go into more of a standardized testing. I know, Sophia, you've been freaking out about some standardized testing. So I grabbed a few problems that are very relevant to what we're doing. And I've been trying to teach you guys a few tips and tricks on how to get through this thing. So I'm going to go and basically give you today what my plan is, and also on Wednesday what my plan is to go through the standardized tests you took on Friday, this past Friday, and also the ones you're going to go through on Tuesday and Wednesday, and just try to do as much of those answer keys as possible. Some of you have found them to be hard. I agree with you, and I disagree with you. Some of them there's tricks, and I'll show you guys the tricks on them. Cool? Yeah, some of you said it was easy, and that's cool too. Some of you said it was hard. You know, I mean, different people will find it different, you know, stuff. A lot of the stuff we did, you know, a lot of the stuff that was on was relevant to what we've covered, you know, so maybe you weren't able to answer questions like that before, but now you can. So hopefully I'll be able to go over some of the answers with you. Anyway, pull up in your standardized test number 1, the one you did on Friday, and let's just go through all the answers on that one. So number 1, let's do that one. 3x plus 4 times x minus 5, and they asked which of the following expressions is equivalent to, and they gave you a bunch of options. I'm not going to write down every single options. Oh, can I make this screen bigger? Let me see. Let me know if this works. Did that change anything? All right, cool. All right, the answer is yeah, you just FOIL it. That's it. You just first, outer, inner, last. You won't believe how many students still have trouble foiling, which, by the way, just to let you know, you guys need to be able to FOIL like nobody's business, especially when we cover rational functions later on, okay? So in January, FOIL it is like the back of your hand. Some tricks I would look for is this. I know the first one's going to be 3x squared. I know the last one is going to be a negative 20. It's almost like I can gain this information straight up from, remember when we did leading coefficients? And we also did leading coefficients and y-intercept. So immediately that crosses out options F, G, and H, because options F and H have negative 9 over here, and G has a positive 20 over here. So immediately, I've crossed out, I've limited it down to 2 options. It went from 5 options to 2 options, just by looking at this. And then, of course, you FOIL the middle, so then I think that it becomes, is it negative 11x? Yeah, that's it. You FOIL the middle, it's negative 11x. Lucas is saying negative 15, and the reason why it's not negative 15x is because you take the 3 and the negative 5 and you get negative 15. That's true, but you also have to add the 4x. So you have negative 15x plus 4x is negative 11x. There we go. That one wasn't hard. Okay, number 2. If x equals negative 3 and y equals 2, then x cubed y plus xy cubed is equal to what? Okay, this is a straight up chug and plug. You just Plug it in and chug it out. That's it. Yeah, you just input the numbers and, you know, it looks harder than it is. I didn't have a calculator when I was solving this, to be honest with you. I was on the bus when I was looking at this, and I just kind of printed this thing out and then did it off the top of my head. So here's the way I approached it. If I plugged a -3 into here for the x cubed, that's going to give me a -9 or something like that, right? Oh no, -27. 9, yeah, 3, 9, 9, 18, 27. Yeah. And then the y over here is going to be -27 times 2. So that's going to be some big number. Got it? That's going to be some big negative number. Okay. The other thing I'm going to look at is if I plugged a y into here, I plugged 2 into here, that would be 2 cubed. Now, I know that most of you guys are saying, oh, this thing's easy. I'm going to not pay attention to what he's saying. Pay attention just a second, all right? If I plug a +2 into here, that makes it +8, and then this is -3. So it'd be -8, or, I'm sorry, -3 times +8. The point that I'm trying to make here is a negative times a positive is a negative number, and a negative times a positive is a negative number. And if I add these two negative numbers together, what am I going to get? I'm going to get a negative number. Exactly, I'm going to get a negative number. And yes, Ethan, you're absolutely right. The numbers you would get is -78, but then again, I didn't have a calculator on me. So when I looked at this, I said, oh, option A and B are positive. Those are out. Options C and D, they're both negative, but one's -6 and one's -30. By this alone, -27 times 2, I know it's not going to be either -6 or -30. So immediately I circle option E without even doing any calculations. I just say, well, that's the only one that makes sense. So what I'm trying to show you here is not how to actually solve the problem, but I'm showing you how I would approach the problem. Okay? And the reason being is because to me, that's a good way to A, mentally check something to see if you're in the right ballpark, or not only that, but also to maybe you can just get these answers immediately. I looked at that when I said the answer's got to be -78. Like it took me 2 seconds to solve. Yeah, -78. There's none other that it could be. I mean, you can go and plug things into your calculator, and that's fine, but I would have just circled E and then be done with that. But then again, if it were on a standardized test, personally, I would circle the answer and say, that's what I think immediately. And then I would actually plug it into the calculator and do it. You see what I mean? Yeah, and I think that after a while you get really good at these. All right, let's try this one. X plus R squared is equal to x squared plus 22x plus r squared. What is R? No. Yeah, what is R? R equals what? Okay, so this is number 3. So remember when I said x plus r squared? I will kick you in the face if you tell me that's equal to x squared plus r squared. Do you recall me saying that? I think I officially used the words boot to the head. I will put my boot in your head. Okay, right. That's not true. That's not true. But if you were to FOIL this, you would end up getting x plus r squared is equal to x squared plus r squared plus 2x or 2rx. I'm going to write it like that. That is a formula. And if you don't believe me, then FOIL it out. So it's this squared. So x plus r squared is actually the first thing squared plus the second thing squared plus, and this thing is going to go in the middle of them, 2 times this times that. Does that make sense? All right. And then so what I just said is, okay, well, if 2rx is supposed to be equal to 22x, then r must be 11. Because 11 times 2 is 22. And that's the only thing that's the only r that would make these numbers match. Because it's not like I can change my x. There's an x in both of them. Boom, done. Does that make sense? If you're totally screwed, then what you could do is you can plug in numbers for r, because they gave you different options. You could plug in your numbers and you could use your calculator, and I guarantee you it will take you about 5 times longer. But if you understand this thing right here, then you're pretty golden. Got it? And so don't ever think that this is the right equation. X plus r squared is equal to x squared plus r squared. That is not true. That is not something. That is something that amateurs make, mistakes make. That is something that little kids make. You are not little kids. I will boot you in the face if you ever do this. But this is true. X plus r squared is x squared plus 2rx plus r squared. The reason why this is not true is because you're missing what we call the cross terms. This is that cross term that you're missing. Does that make sense? Will standardized problems be on your semester exam next week? The answer is no. The standardized problems will not be on your semester test next week. However, the standardized problems that you're doing now, where you have 4 choice chances on Friday, and then the one that's on Tuesday and Wednesday, or I think Monday, and I don't know when they're due, like in the next 2 days. Those ones are going to be a part of your final exam grade. So you'll have chances to do it, and you'll have multiple chances, and they're multiple choice, and it's going to be a part of your final exam grade. So those aren't regular assignments. Those are actual exam assignments. So take them seriously. Got it? All right, let's move on. I'm going to hit these things quick, and I think I'm spending way too much time on this. I don't even know if I'll... Will you get a study guide for the final exam? The study guide for your final exam, what is the best way to study for this final exam? I'll be honest with you. Here's what I did for your final exam. I feel like what I did was I went through your homework and I chose problems that I didn't give you in actual homework. So, you know, on all of the curriculum, they gave me a whole list of problems to do, right, to assign you. And I only chose certain ones for the homework, right? Well, what I did for your exam is I chose the problems that I didn't assign you, and I gave you those. So what I'm saying is, the best way to not freak out about your final exam is to not freak out about, is to be able to do your homework. Yeah, your final exam aren't going to be problems straight off of your homework. They're just going to be like problems that were right next to your homework. Or maybe I'll take a look at the homework and I'll make up a problem based on that homework. It's going to be almost just like your homework. Got it? So nothing to stuff. Bradley is confused on the, what is it? What does that say? Last problem? On the last problem. Are you talking about this one? Is that the one you're talking about? I'm sorry, there was an X and an R there instead. I put an A and a B. It's because when I told you to memorize this, this is the formula that I have in my head. You can change it to X and R and it would be the exact same thing. Okay. The reason, Bradley, is because the one I saw was they told me X squared plus 22X plus R squared. And then I said, okay, well that's supposed to be equal to X squared plus 2RX plus R squared. So what I ended up doing was I ended up saying, well, if 2r is supposed to equal to 22, then what does r need to be? You see what I'm saying? I'm comparing terms. This thing is the same, this thing is the same, so the only thing that's different is this 22x needs to be the same as the 22 or the 2r. Because these are equal to each other. Oh, okay. Well, I mean, I figured you'd be able to tell me what r is if I told you 22x is equal to 2rx. I guess one way to solve it is exactly how Sophia says is, all right, the x's are the same, but the things that are different is the 22 is supposed to equal to the 2r. So then divide by 2 and r is equal to 11. All right, moving on. Question 4. I'll be honest with you, I probably might only just get through these 10 problems. I wanted to do more, but let's see what we got. Question number 4. Okay, here we go. X plus 1, x minus 2, x plus 3, x plus 4. F of x, this is number 4. F of x equals this. How many zeros do you see? 4. Duh. I agree. This is exactly what we were just learning. In fact, I could even go on to ask you not only how many zeros, but what is the degree of this function? It's 4. What is the leading coefficient? Well, it would be 1, 1, 1, 1. So it's 1. What is the y-intercept of this function? That would be, I don't know, that one's a little bit tougher. That one is negative 24. Because you just take all the last numbers and multiply them out. That's it. But I mean, the easiest question I think I could have asked you, which I did, was how many zeros are there? Cool. Maybe here, let me switch this one up on you just to make it a little bit more interesting. What if I did this? What is the degree of this function? All right, the degree is 5. How many zeros are there? There are 4 distinct ones, exactly. At this 0, it happens to not, it doesn't cross twice at x plus 1. What happens is it kind of kisses it at x plus 1. But there are 5, there are 5, it's a 5th degree polynomial, even though there are only 4 zeros. So, I mean, see how good you guys have gotten? I just made this problem harder, and I think that would be an even better question to ask on this SAT question test, but they didn't. All right, number 5. G of x is equal to 3 times x squared minus 2. They told you g of x is equal to 69. And so what is 2x minus 3? All right, there's a few parts of this one. You don't know how to do this one. Okay. If this is g of x and that's g of x, would I be able to write down this without confusing you too much? Oh, and by the way, this is number 5, I think. Does this work for you? Well, they told you, they said, if g of x is 69, what is this? So they told you g of x is equal to 69. Okay. So I just said, all right, well, if this is g of x equals that, then that equals 69. All right, solving that. X squared minus 2 equals 23. X squared equals 25. X is equal to plus or minus 5. We cool? Not hard. Okay. Now all you do is you plug plus or minus 5 into here. If I had plus 5, then I would have 2 times 5 minus 3. That would be 7. Positive. If I chose to plug in the negative 5, that would be 2 times negative 5, which is negative 10, minus 3, which is negative 13. Not negative 7, just negative 13. Something different. So my options are, the only option is 7's on there, negative 13's not on there. So I would choose that answer. I think the answer is K, the last one. Does that make sense? All right, number 6. So this is still within the realm of what I taught you. I just taught this to you a long time ago. This one is the hardest one, I feel like. It said something about m plus n is even. M plus n squared plus n plus p is odd. All right? What is true about this? Okay, well, let me ask you this. Does m have to be even? Or, well, I guess here's the question is, if m is even, what does n have to be? If m is even, then n has to be even. So then n is even. And I'll be honest with you, I feel like a lot of you folks are saying, are getting really confused by this. And I think it's because you guys are trying to think of all these abstract cases. All right, let me show you the easiest way to solve these problems. All right? If m is 2 and n is 4, 2 plus 4 is 6. 6 is an even number, so m is allowed to be 2 and n is allowed to be 4. Are we cool? So, if that's the case, then what is this? Okay? This would be 2 plus 4 squared plus 4 plus p. Got it? 2 plus 4 is 6. Square that is 36. Plus 4 plus p. That would be 40 plus p. What does p have to be in order for this to be odd? Then p is odd. We cool? Then what I say is, okay, well, what about the other case? What if m is 1 and n is 3? That is totally allowed to be the case, because if m is 1, n is 3, then m plus n is 4, which is even, so it still follows our logic. Then I literally plug these numbers in, and I say, okay, well, what's going on? All right, so that would be 4 squared plus 3 plus p, so that would be 16 plus 3 plus p, so that would be 19 plus p, needs to be an even number, then p is even. Did I confuse anybody? Okay. What I'm saying here is, all right. What, I can't see your question. It's way over there, and I'm stuck behind this piece of glass. Type in your question again. All right. And hopefully I can finish this thing off. The rest of them are pretty easy. All right. Let me explain this to you, Sophia, because I only have time for that. I'm just going to show you what I did, all right? Some students can get all lost in the hypotheticals, like they try to think abstractly, like if m is even, then n is even, then this and all that kind of stuff. I say just plug in the numbers. Just plug in numbers. Choose an even number. Choose another even number. Figure out what p has to be. You can deal with numbers. They're very easy to deal with. Why did I choose 2 and 4? Well, because 2 and 4 are the smallest even numbers I can think of. And I don't want them to be the same because sometimes things get funky when they're the same number. So I wanted to choose 2 of the easiest even numbers I can think of. 2 and 4. For the odd case, what are the 2 easiest odd numbers I can think of? 1 and 3. When I use those numbers, I figured this thing out. Does it make sense to you? And the correct answer is J. The only answer that made sense is they said if n is even, then p is odd. Because it doesn't guarantee you, this whole story doesn't guarantee you that p is odd or even. It doesn't guarantee you that m or n is odd or even, but it does say that if n were even, then p is odd. All right. It didn't say m is even, it only said they're even together. Yes, exactly. You're right. You're absolutely right. But what I'm saying is m plus n is even. So if m is 2, if m is even, then n has to be even as well. Right? Because an even number plus an even number is an even number. So I chose the 2 easiest even numbers I could think of. And also, in this case, if m were odd, then can m be odd? Yes, absolutely yes. It could be 1. But n would have to be odd as well. 3. Because an odd number plus an odd number is an even number. Right? So as long as they're both odd or they're both even, that's cool. I just wanted to choose a case where I chose the 2 easiest odd numbers I can think of, 1 and 3. Can't get any simpler than that. I gotta erase. I gotta move on. I'm gonna finish at 12:15 because I want to work with my chemistry students on a new topic that I'm making up. Got it? All right. Question number 7. This one was easy. 9 minus x cubed plus 2 equals 19. This is number 7. All right. Literally just pull everything over to one side and solve it. So I think it's just like, it's going to give you negative x cubed equals 8. And so you know that x is equal to negative 2. There is maybe one thing that you need to know how to do is figure out how to take the cube root of something on your calculator. There is no cube root on your calculator, but there is you can plug in 8 to the 1/3. You can plug that into your calculator and it will give you the right answer. Because 8 to the 1/3 is the same as taking the cube root. Got it? All right, what about this one? Number 8, it gave you x squared minus 3x minus 2 plus 2x times 4x minus 1. Literally, all this one was distributing and combining like terms. So that one answer is C. Got it? Not hard. All right, question number 9. Oh, question number 9 is also a plug and chug. I told you I didn't put this in order as far as like easiest to hardest. I just put it in any order. 2x squared minus 5x minus a equals 0. What is a equal to? If x is 3, then a is what? Okay, fine. All you do is you write this down, plug in x equals 3. So that would be 2 times 9 minus 5 times 3 minus a equals 0. 18 minus 15 minus a equals 0. 3 equals a. There's your answer. Which is interesting because if x is 3, then a is 3, and I'm sure that they did that just so that you could second guess yourself. Because you're like, wait, why are they the same? They shouldn't be the same. And my answer is there's nothing stopping them from being the same. So deal with it. All right. 3x squared minus 5x plus 2 equals 0. Oh, I'm all out of time. I'm sorry. All right. This one is super easy. There's two ways to do it. You could factor. And if you remember how to factor with the leading coefficient not being a 1, good on you. You'll literally end up getting this. 3x minus 2, x minus 1. The easier way to do it, to be honest with you, the easier way to do it is, remember I told you, all polynomials can be all quadratics can be factored using the quadratic formula. It is your bazooka. It takes a little bit of extra time, but it's not bad. All you do is you just literally plug that back into negative b plus or minus the square root of b squared minus 4ac all over 2a. And you'll end up getting 5 plus or minus the square root of 25 minus 24 divided by 2. And you'll end up getting the answers right off the bat. This gives you the answer. This gives you the answer. This one requires no creativity or thought. It just requires you to plug it in, chug it out. Does that make sense, Lucas? All right. The last one I want to do with you is this. X minus 1, 4 minus x is less than 0. All right. I don't have any time. I'm all out of time. Can I immediately say my points of interest is 1 and 4? My zeros are at 1 and 4. Are we cool with that? All right. Because I don't have enough time, I'm not going to test regions, which is the official way of doing this. But here, let me show you the cool way of doing this. If I were to FOIL this out, what would the leading coefficient be, a positive or a negative? Bear in mind that there's a negative x over here. And there's a positive x over here. So the leading coefficient would be a negative parabola. So my parabola should look something like this. And then literally what this thing is asking you is, when is this thing negative? Okay, I'll tell you. Here and here. I mean, we could go through and test regions, but that's the quick way of doing it. Yes, that's exactly where it stands below the x-axis. That's when y is negative. All right, I'm sorry, I gotta go. Moving on to chemistry, which is a really cool topic. So please, those of you in my chemistry class, join the chemistry